This is a short review for EECS376 IA application. I will introduce a question from the midterm exam of last semester. Consider a language that decides the motion of a point starting at O and consists of only three labels. This is turning left, and this is turning right, and this is going straight of one step, and this point can only stay in the integer points. So if it's straight, then it goes 1 point, and turns left, turns its head to left by 90 degrees. And if then it goes straight, then it will go right for 1 step, like this. And we need to show that the language that the point will return to O finally cannot be decided by a finite state machine. And we will record the usual steps to prove that a finite state machine cannot decide some language. First, we need to use the property that finite state machine have only finite states. So we could use pigeonhole principle to show that two inputs will force in the same state. And note that if a finite state machine is in same state and the later input is the same, then its final input, that is accept or reject, will still be the same, because it will not remember anything before its input. And then we need to show that the machine cannot accept or reject both of the input, that it must accept one and reject one. So now we'll consider a simple group of input because we don't want to prove something that's much complex. So we only consider the motion of the point on the y-axis, that it first goes straight for n steps, and then turn right, that is turning 180 degrees, and go back. So we will first consider the first part of the input, that is go straight for n steps. If the finite state machine have only s states, then we could take s plus 1 inputs that goes straight for 1, 2, 3 steps, until s plus 1 steps. Then there must be two inputs that goes different steps forward, away, but they will fall in the same state of the finite state machine. Like this, when assume that the two inputs have n1 steps forward and n2 steps forward, then at the arrow points here, like at this point of the finite state machine, those two machines is in the same state. Then consider input of 2 turning right and both input of n1 back. Then by the definition of the language, the machine should accept this one, but should not accept this one, because this do not return to the original point. But because they are in the same state at the arrow point place, and the later inputs are all the same, that is turning right by 2 times and go back to n1 times, they should fall on the same state at last. So because finite state machine can only accept or reject by its current state, then they cannot defer those two inputs. That is to say, they must accept either accept or reject all. So that's not possible for the input. So here comes the contradiction, and this language cannot be decided by finite state machine. Thank you for watching the video.